Hi viewers, I am Dr. N. Uttarasamy, Professor, Department of Mathematics, KS Rangasamy College of Technology, Tiruchengood, Namakkal, Tamil Nadu, India. In this video, we are going to discuss linear differential equations of second and higher order. First introduction, a differential equation is of the form f of x comma y dy by dx, d square y by dx square, comma and so on d power ny divided by dx power n, that is equal to 0, in which the dependent variable y of x and its derivatives y dy by dx, d square y by dx square and so on occur in first degree and are not multiplied together is called a linear differential equation. This linear differential equation with the constant coefficients we are going to see. A general linear differential equation of nth order with the constant coefficient is given by k naught dny divided by dx to the power n plus k1 d to the power n minus 1 y divided by dx power n minus 1 plus and so on plus k n minus 1 dy by dx plus k n y, that is equal to capital F of x. This is linear differential equation general form for the nth order. So here all k's, that is k naught, k1, k2 and so on up to kn are constants. And this right hand side f of x is a function of x alone or constant. So this equation can be written as k naught d power ny divided by dx to the power n. This can be written as dny. So k naught dn plus k1 d to the power n minus 1 plus and so on plus kn minus 1 d plus kn into y. That is equal to f of x. So here dn is equal to d power n divided by dx to the power n and so on are called differential operators. Solving linear differential equation with the constant coefficients, the complete solutions of the given equation f of dy is equal to capital F of x is given by y is equal to complementary function plus particular integral, whereas CF we are denoted by, that is what CF be the complementary function and PI be the particular integral. When in the right hand side f of x is equal to 0, then the solution of the equation f of d into y, that is equal to 0, is given by the solution y is equal to only complementary function. So what are the rules to finding the complementary function? That is CF. Consider the equation f of dy, that is equal to capital F of x. This equation already we know, we can write. First step we are going to take d is equal to m. Then the auxiliary equation is given by f of m is equal to 0. So just we have to substitute d is equal to m. There is a right hand side that is equal to 0. This is equation number 3. Next step, solve this auxiliary equation is given by. So using synthetic division, whatever it is, we are going to find the roots. The first case 1, if the roots are real and distinct, that is roots are real and different. Say the roots are m1, m2, m3, and so on, mn. So we can write this complementary function CF, that is there is a C1 be the constant, C1 e power m1x plus C2 e to the power m2x plus and so on plus Cn e to the power mnx. So for n roots of the auxiliary equation. So this in the first case roots are real and different. So our roots we can take it as m1, m2, m3 and so on up to mn. Second case, if two or more roots are equal, that is, let us take m1 is equal to m2, that is equal to and so on mk. So here in this case, for any roots are repeated, that is same roots, that is equal means, we can apply this case too. So that is c1 plus c2x plus c3 x square plus and so on plus ck x to the power n minus 1 into e to the power this common, that is m1 is equal to m2 is equal to, that is equal to, that is what, common mx plus and so on. Suppose the roots are equal means, that is 3, 3, there are only two roots, 3, 3, we can write the complementary function c1 plus c2x into e to the power 3x, that's all. Then third case, if the auxiliary equation has a pair of imaginary roots, that is m1 is equal to alpha plus or minus I beta, or m1 is equal to alpha plus I beta and m2 is equal to alpha minus I beta. The roots are imaginary. So in this third case, roots are imaginary means complementary function, that is equal to e power alpha x into c1 cos beta x plus c2 sin beta x plus remaining roots are real means we can follow the same in the first case, c3 e power m3x plus and so on up to cn e to the power mnx. So this is the third case. Suppose if two pairs of imaginary roots are equal, that is m1 is equal to m2, that is equal to alpha plus I beta. Similarly in the second case, that is m3 is equal to m4, that is equal to alpha minus I beta. Then the complementary function e power alpha x into c1 plus c2x cos beta x plus c3 plus c4x sin beta x plus and so on up to cn e to the power mnx. So these four cases are very, very important to find the complementary function. So we can take a simple problem. Solve the differential equation d square y divided by dx square minus 8 dy by dx plus 15y, that is equal to 0. So already we know d by dx we can write d, and also d square by dx square we can take d square. This y be the common. So in this equation we can write, that is what, d square y minus 8 dy plus 15y, that is equal to 0. So commonly we are taking outside this y, that is d square minus 8m plus 15 into y, that is equal to 0. Then we can write the auxiliary equation, that is d is equal to m. So this equation can be written as m square minus 8m plus 15, that is equal to 0. So using any one of the method, we can easily find the roots of the given equation. So in this, if we solve this equation, m square minus 8m plus 15, that is equal to 0. So m square means m has two values. So what are the values? That is what, 3, 5. The roots are m is equal to 3 and m is equal to 5. That is what, 3, 5. So let us assume m1 is equal to 3 and m2 is equal to 5. So in this problem, the roots are real and different. So therefore the complementary function c1 e power 3x plus c2 e to the power 5x. So here c1 and c2 are constants. So for our convenience, c1, c2 are a, b, c. So we can assume that is these constants. So here in this problem we are taking c1, c2, c3 and so on. And then in our problem, the right hand side, that is capital F of x is equal to 0. Therefore the solution is given by y is equal to complementary function only. So therefore y is equal to c1 e power 3x plus c2 e to the power 5x. Second example, d cube y divided by dx power 3 minus 6 into d square y by dx square plus 11 into dy by dx minus 6y, that is equal to 0. So what are the solution? So for the solution, first one we can write d cube minus 6d square plus 11d minus 6 into y, that is equal to 0. So put d is equal to m. The auxiliary equation m cube minus 6m square plus 11m minus 6, that is equal to 0. Then by the heat and trial, m minus 2 is a factor of this equation 1. This 1 can be rewritten as, that is, this equation m cube minus 2m square minus 4m square plus 8m plus 3m minus 6 equal to 0. So using synthetic division, we can easily find out the roots. We can get the same root, that is 1, 2, 3. So the roots are real and different. So m1 is equal to 1, m2 is equal to 2, and m3 is equal to 3. So therefore, what is the complementary function? C1 e power x plus C2 e to the power 2x plus C3 e power 3x. In this problem, right hand side, that is equal to 0. Therefore, the final solution y is equal to C1 e power x plus C2 e power 2x plus C3 e power 3x. Similarly, we can solve the third one, that is d cube y by dx power 3 plus 2 into d square y by dx square plus dy by dx, that is equal to 0. And this auxiliary equation m cube plus 2m square plus m equal to 0. Therefore, m is equal to 0, minus 1, minus 1. So in this problem, minus 1, minus 1, that is minus 1 is repeated. So the first one, C1 e power 0x, e power 0, that is equal to 1. So therefore C1 plus minus 1, minus 1, this roots is repeated. So C2 plus C3x e power minus 1x, that is what? E power minus x. So therefore, in the right hand side is 0. Therefore, the complementary function, that is our solution, that is y is equal to C1 plus C2 plus C3x e power minus x. The next problem, d power 4y divided by dx power 4 minus 2 into d square y by dx square plus y is equal to 0. And this equation can be written as d power 4 minus 2d square plus 1 into y, that is equal to 0. Then the auxiliary equation, m power 4 minus 2m square plus 1 equal to 0. This equation, if we solve this equation, m power 4, m has 4 values. What are the values? Are minus 1, minus 1 and plus 1, plus 1. So in these two roots are repeated, minus 1 and 1, 1. So therefore the complementary function C1 plus C2x e power minus x plus C3 plus C4x e to the power plus 1x. So this is the solution.